We are talking about quadrilaterals, and we want to test for parallelograms. We want to recognize the conditions that ensure a quadrilateral is a parallelogram, and we want to prove that a set of points form a parallelogram in the coordinate plane. So we want to decide if it is a parallelogram or just a quadrilateral. So ways that we can check to make sure that it is a parallelogram. Both pairs of opposite sides are parallel. So this would be a parallelogram, and we could mark this with 3 arrows here and 3 arrows here. That means that these opposite sides are parallel. And we could mark 2 arrows here and 2 arrows here, and this would signify that opposite sides are parallel. Both pairs of opposite sides are congruent. So we could show that. Similarly, we could mark 3 congruent marks here and 2 congruent marks here, and that would show that opposite sides are congruent. Next one, both pairs of opposite angles are congruent, and we simply show that. We could show that this angle is congruent to this angle, and this angle is congruent to that angle. And that would say opposite angles are congruent. We can continue on. And the next one that we will talk about is consecutive angles are supplementary. Consecutive angles are supplementary. And we're going to use this bottom box right here. So if we said that this was angle 1, and this was angle 4, and 2, and angle 3. So supplementary means that they add to 180 degrees. Angles add to 180 degrees. So we could say the measure of angle 4 plus the measure of angle 3 is equal to 180 degrees. And then we could say the measure of angle 1 plus the measure of angle 2 is equal to 180 degrees. And we could say the measure of angle 1 plus the measure of angle 4 is equal to 180 degrees. So those are consecutive angles, and we'd have to show that multiple consecutive angles added to 180 degrees. And this illustrates consecutive angles are supplementary. We have 2 more that we want to check, and that is diagonals bisect each other. And if we want to show that diagonals bisect each other, we would have to show that this portion of the diagonal is congruent to this portion of the diagonal, and these 2 portions of the diagonals are congruent as well, and that would be diagonals bisect. And the last one we could have is one pair of opposite sides parallel and congruent. So we could use either side. We could show that this side was parallel and also congruent. We could use either side, but if this side is parallel and congruent, then it is a parallelogram. Opposite sides parallel and congruent. So these would be 6 examples of how we could recognize the conditions that ensure a quadrilateral is a parallelogram. Those are the 6 conditions that would ensure that it is a parallelogram. The last one, the last objective, prove that a set of points forms a parallelogram in the coordinate plane. In order for that to happen, we'd have to prove one of those 6 conditions true, but we would have to prove it using these formulas. So we could use the distance and the distance formula, which is right here, and that would show us that opposite sides are congruent, and we'd have to check multiple distances. We could use the midpoint formula to check that diagonals bisect, and we'd have to do this twice in order to check that the diagonals indeed bisect have the same midpoint. And check the slopes. We'd have to check that opposite sides are parallel, and we'd have to check all the slopes in the line to make sure that all the lines are parallel.